Imagine a planet like ours, but not ours, on another star, revolving around another star, somewhere far, far away, a bigger star, a more massive star, far a greater star in terms of size, proportion, and just general volume than our own star. That star is large enough to blow up one day, to end in a violent supernova explosion. Think about the planet that was revolving around, and imagine that it was far enough away from the star to actually survive the explosion. So you imagine the star blowing up into this massive explosion. Its guts, gases is spewing out and into the void. And this star that's out there, this planet out there, gets bombarded, hit by this giant wave of this concussion from the exploding star, and then the gas comes through and pushes out. Now, this planet then is hurtled away from the star into the void, along with all the gas that made up the star as well, or most of it, the gas. And then we go out, we have a nebula then, an interstellar nebula out there floating around, slowly cooling in this little planetoid. Now that is basically dead, of course. And any atmosphere, any oceans, any life, it would have been boiled and stripped away in the explosion. But nonetheless, we have a little rock, a little core floating about in a gas cloud that's slowly cooling and congealing. Now, what might happen next? Well, the gas that is floating around in basically a uniform system is swirling a bit, and there's eddies and moving about, and it begins to collect in places where, due to gravity, collect in places where there are points of density points that can draw the atoms in, the atoms of gas in. And now what would make a great point of density in that case? This little planet, this little planetoid that has been basically hurled out into the night from that dead star, will make a great center of gravity for the gas to begin swirling in and falling in and having basically an atomic rain. What I mean by atomic, of course, is atoms. Atoms raining down onto this planet, this dead planet, slowly accumulating. And as it becomes more massive, it becomes, the gravitational attraction becomes greater, and it gathers more ability to draw more atoms in. And guess what happens? Over time, it becomes a gas cloud itself, with a little a gas ball itself, with a little planet at the core, a little rocky planet there at the core. And if this continues on long enough, guess what's going to happen? It's going to reach a certain mass, and it will switch on, turn on, and become a star of its own. Now, I don't know what would happen to the little rocky core at the center there. Would it remain at the core? Probably not. It would probably be crushed by the awesome gravitational pull of all those items that are in there, and its elements would be rendered down to their constituent parts and scattered throughout the stars, well, in whatever order elements are. But it's an interesting thought to think that the planet of a one solar system may in turn serve as the seed. If it can survive the explosion of a very large star, it could then in turn provide the seed for the formation of a new star. This isn't a new idea. This idea about stars forming from the death of other stars has been around for a while. But I like the idea of one planet possibly pushing through the death of one star and helping to form the life of a new star. Interesting idea. At least I had fun thinking about it at length. Hope you guys have a great day. Take care.